All right, Mathemedians, here we are back from spring break, and it's our first video notes. That's right. We are moving into geometry. So we have identify polygons. And one thing I noticed I did not put on this sheet was, how do you know it's a polygon, right? So put a little star right there and go all the way to the bottom and put a star right there. And we're going to say a polygon is a closed two-dimensional figure that has straight lines. Okay, so if you have curved lines, then it's not a polygon. And if it has not closed all the way up, if it's got an opening still, then it's not a polygon. Okay, it is a closed two-dimensional figure that has straight lines. All right, so let's go to the top of our page now, and we have 3 words that are vocabulary you need to know when we're talking about polygons. We have a vertex, okay, and a vertex is each angular point of a polygon or a polyhedra, which we'll figure out when we get to our second unit, or other figure. Now, vertex is one of those weird words in English that when you make it plural, it changes. Okay, so like mouse is mice, right? Vertex is vertices, V-E-R-T-I-C-E-S, vertices. That's the plural. So you have one vertex and many vertices. All right, now side, that would be the line segment. I'm going to switch colors. The line segment that joins 2 vertices in a shape or two-dimensional figure. Okay, and then our last word here is angle. All right, now angle, this is the space usually measured in degrees. Okay, when we talk about angles, we have a 50-degree angle, a 90-degree angle, and so on. So the space, which is measured in degrees, the space between 2 intersecting, okay, I-N-T-E-R-S-E-C-T-I-N-G, intersecting lines or surfaces at or close to where they meet. Well, where do 2 lines meet? They meet at a vertex, right? So they're all going together. So we've got different shapes down here. The way to identify a polygon is basically count how many sides, how many angles, and how many vertices. All right? So that's what you want to make sure that you are focused on. So like this one, 1, 2, 3 sides, right? Because this is a side, and this is a side, and this is a side, right? So 3 sides gives us a triangle. 1, 2, 3, 4 sides gives us a quadrilateral. Big giant word. And I need to pause for a moment. All right, I am back. You probably didn't even miss me, didn't even notice. But we're going to move on. We just did the quadrilateral. I showed you that you count the sides. You also need to know about the vertices and the angles, okay? The triangle, we said, has 3 sides. It also has 3 angles, and it has 1, 2, 3 vertices. Those little points where the 2 lines come together, boom. So this has 3 of everything. The quadrilateral, believe it or not, has 4 of everything. 1, 2, 3, 4. 1, 2, 3, 4. So this one, 1, 2, 3, 4, 5. Look at that. By the way, I hope you're noticing that all the sides are equal as well. Okay, so this is 5 sides that are of equal length. If I pulled out a ruler, it will be. And you'll want to be using a ruler in the next lesson or two, as well as a protractor. So anyway, this has 5. 5, anybody know what the prefix is for 5? Because our government has a big giant building that's in this shape. It's called the Pentagon. And that's what it is. 5 equal sides, 5 equal angles, and 5 vertices. Let's move on. Next one, we have 1, 2, 3, 4, 5, 6 sides, 6 equal angles, and of course 6 vertices. 6 is called a hexagon. All right. Up next, I bet you can guess. 1, 2, 3, 4, 5, 6, 7. 7 is called a septagon. No, I did not say Decepticon. I did not say that. We are not in cartoon land. We are in math land. So it is a septagon. This one, 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, that would be an octagon, kind of like an octopus, because it has 8 legs. Well, this has 8 sides. And angles and vertices. Here we go. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. Okay, count. Here we go. 9. That would make this a nonagon, which is an interesting word. That's a gon. No, it's a nonagon. Ha, ha, ha. All right, last one. Guess with me. Yes, it's going to have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes this a decagon. Okay? So, remember, a polygon is a closed two-dimensional figure that has straight lines. If you see a curved line or a wiggly line, it's not a polygon. If you see something that's not closed all the way up, it's not a polygon. All right? And how do we tell what kind of polygon? We count how many sides, how many angles, and how many vertices. All right? Go do your math practice, and I'll see you when I see ya.